Okay, so far we've been defining energy as the ability to do work, but we haven't defined what work is. So that's what we're going to do with today's lecture. When work is done on an object, two things must happen in order for us to consider work being done. The first is that you have to place a force on the object, and the object must move as a result of the force in the direction of the force. So we can calculate work then, if that is the definition of work, the force that you place on something in the moving the object in the direction of the force. We can calculate work to be the force that you placed on the object times the distance that you move the object. The unit is the Newton meter or the joule. So that is why we say that energy can be defined as the ability to do work. If you noticed, work and energy have the same unit. So we're defining energy now as the ability to do work. Doing work on an object will change how much energy the object has. It'll either take energy away or give energy to the object. This brings us to something called the work energy theorem. If there is a change in the total mechanical energy of an object, then some work has been done to the object and heat must be generated. So mechanical energy we're going to define as how much work is being done on the object. The change of mechanical energy is equal to how much work is being done to that particular object. So if I put energy in, the amount of energy that I put in, that change is how much work I've done on that object. So the kinetic energy of an object is equal to the work done to put that object into motion. So if I have an object that is still and I change the amount of energy, so now the object is going from potential energy to kinetic energy, that change of kinetic energy is how much work was put in. Okay, this can also apply to potential energy as well. The amount of work equals the change of potential energy. So if I'm converting from potential into kinetic energy like we saw in the activity that you did, then that change of potential energy is equal to the work. So the work equals, the overall mechanical energy is how much potential and kinetic energy that you have. So the change in your potential changes your kinetic, so both of those changes are equal to the work that's being done to the object. Okay, so delta PE represents any change in potential energy there. So this concept in physics emphasizes that the importance of energy changes. If an object does not experience a change in total mechanical energy, then no heat has been generated, no work has been done. Just as work is necessary to put an object into motion, work is necessary to slow and eventually stop an object. And so this change in energy that you're seeing is converted into a different form of energy, so there's heat that's generated. If the kinetic energy doubles, the work needed to stop the car would double then, according to the work energy theorem. When a car stops, what happens to its kinetic energy? Is it created or destroyed? No. We learned from the law of conservation of energy that energy cannot be created or destroyed. So what happens? It's transformed into another type of energy. And what type of energy does the work energy theorem say that is? More than likely heat. So this is another example of these two laws, this theorem working together with the law of conservation of energy. Energy is not being created or destroyed, it's being transferred to the surrounding area and transformed into heat. And this also can explain that executive pendulum that we talked about before. When one ball hits another, it's transferring its energy and it's transforming it, and it's transforming it into sound, and we also said into heat. So anytime work is being done on an object, there's an energy transformation involved, and that energy transformation is in the form of creating heat. Okay, so that ends our discussion on work, and we are going to be taking a look in class at doing some work problems and some work theory as well.